Hi class, in this video we're going to be talking about the WCF Windows Communication Foundation, and let's take a look and see what that is. Windows Communication Foundation is a series of services, and it allows for consistent internet-based communications. And in the past, before WCF, there were many different methods and protocols or standards for communicating across different platforms, like via the internet. WCF offers a unified platform. This is in a web chapter that's available to you on Canvas. So take a look at that. To think about a web service, to think about using your ATM. If I'm at my bank, I can use the ATM and I can withdraw money or make deposits or whatever I want to do. But what if I'm traveling? If I'm overseas or just down the road, I may need to use an ATM at a different location. And by using a web service, the bank can handle both of those transactions irregardless of location. And how that happens is the bank hosts a WCF, Windows Communication Foundation, process on their web server, and then clients can, like our ATM, can connect to that web service to communicate with the server. So in the example of my ATM, the first communication might be to establish the account settings, and then to find out if there's available funds or to deposit funds into the account. Each of those communications is handled using a WCF messaging format. Remember, we have to be speaking a consistent language on both of these machines, or we're not going to be able to communicate properly. We can't just have disparate programs out there communicating successfully. Now, because we're using WCF, we can have multiple clients or multiple ATMs connecting to our service, running on our server, and getting their own pieces of information. So this allows us to control our code, have it running on our server, and allow clients to connect to it. WCF accomplishes these tasks through a series of common controls, and some of the different things that are a part of WCF are .NET remoting, so that our .NET application doesn't even have to worry about what location it's communicating with another program on. ASMX, which allows us to interoperate with different platforms. WSE, our protocol support. We have enterprise services that lets us do attribute-based programming, our class level stuff, and then message processing in our system messages give us this capability to communicate back and forth across these different machines or different processes. So WCF is a class that allows methods to be called from other machines, and it can handle common data formats and protocols like XML, JSON, and HTTP. Now, we've used most of those in our class. HTTP is just a standard web protocol that we use when we're running a web browser. So it's very easy for us to communicate with WCF if we're using a really common protocol like HTTP. XML and JSON are a little bit more specialized, but again, common protocols that we can use. The class itself, our service, is saved on a machine, usually a web server, and then we allow all other machines or authorized machines to access this saved DLL. This makes this function distributed, and it can run over the internet or it can run locally on our own network. Whenever we're working with WCF, we're going to be using a couple of different protocols for our messaging formats. We have some choices. One available protocol is SOAP, Simple Object Access Protocol. This is an XML-based protocol, and XML describes how the requests and responses should be sent and received. Now, over the internet, it can use a common protocol like HTTP, and we wrap our data message in XML code, which then gets wrapped in HTTP protocol code, and all of those messages can be transferred across the internet successfully. Now, the other alternative is REST, or at least that we're going to talk about, Representational State Transfer Architecture. And this architecture gives us a request response mechanism, which means I can post a request to the server and then get that request when it's sent to me. In this case, we're using straight messages that don't have to be wrapped into these other protocols as SOAP does. So it's a more straightforward protocol. When we're using a GET, we can send a plain text data message using REST. And when we're waiting for a post or sending a post, we can't see the data because it's embedded internally in the communication channel, so it is harder for hackers and packet sniffers to grab. So what do we want to use, SOAP or REST? We have to decide. Now, no matter what, we're going to have some components that we have to be prepared to document and explain. First of all, our address. This is going to be the location of our server. Is it sitting on some URL, www.myserver.com, or whatever kind of situation we have it set up in? Now, this is going to be my endpoint. And this is where I'm exposing my open address for a service for connection. My address is going to include some information about the protocol. Now, next, we're going to include binding information. How are we going to communicate? Are we going to use SOAP? Are we going to use REST? We might have additional security constraints. And then we have to establish contracts. And contracts define some of this information for us. Mostly the interface. The interface is what's exposing this web service on that endpoint, and this interface is going to allow us to choose what we expose. Our host is going to be considered our web server, the server that has this service running on it. Now, those web services hosted on this server, I keep saying that, but I want you to really be thinking about it, that I just have one server, maybe an Amazon web server somewhere, that is hosting this service, and no matter where my clients are, they're connecting. So client 1 might connect via the internet to a specific endpoint, a given method that's available from this service, endpoint 1. Another client N, might connect directly through our local intranet, and he connect again to another endpoint or that same endpoint. So our service definition decides what's going to be available and exposed as connection points. As a client, when we connect to this service and communicate and use data, we're consuming that service. We're consuming its offering. So in this picture, I'm a consumer over here, and I could be using Visual Studio that's connecting to a WCF client. Internally, it's going to make some sort of connection depending on, all of the different protocols we've chosen. And then we will connect to an endpoint on our server. Whenever we establish a connection, our client is going to start by requesting a service. The server is going to respond with information about how it can handle that service. Well, I need you to connect using port 80 HTTP, and are you going to be using a SOAP transfer? And the client is going to respond saying, yes, that's fine, and yes, I have the proper security, depending on the requirements. The server will then respond, okay, and now they can begin communicating meaningful information. As they're doing this, they will both be utilizing the network stack on their machine that gives them these WCF capable messages. So our client will be going through this series of formatting requests, basically. Because of Visual Studio, all of their messages are going to be set up in the correct format, depending on what we've chosen, and then they'll be transferred using the network, our transport channel, to the server. The server then is going to de-encapsulate all of that information to pull out the message and find out what exactly is being requested from the client. Now on our end, it's going to look like this message is just being transferred directly back and forth. But we need to remember, behind the scenes, there is this encapsulation going on where we're wrapping this message in whatever requirements it might have, and then de-encapsulation at the server, and then when the message is being sent back. Again, there are many layers that are involved in this process. Now, there are many layers. It is kind of complicated. Are there benefits to doing things this way? Well, you bet. We saw the first one using an ATM. We wouldn't have those kinds of things capable, or if we did, they would have to be very specific to a certain company, like a development that they had made. So these distributed computing offerings allow us to access data from any location, perform complex computations, and make sure that our data integrity is validated. We can have multiple clients accessing one web service. So one example that students have mentioned in their job might be where their company's cash registers are actually communicating with the corporate office to get pricing information, and the corporate office then can set up that pricing information on one service, on one server, and in effect update all of the locations. So that's a great way for us to be able to handle those kinds of things instead of sending those updates out to hundreds and thousands of locations. So we're going to create a project here, and we're going to be using that web chapter that's available in Canvas. So I'll be going along with it pretty close. It doesn't have a lot of screenshots, so we'll be trying to follow the narrative. Now we're going to try to create a test service, and we're going to create a service named WCF Test Service. We want to do this because we want to do some renaming of the default names so that we can see, where these things are affected. And then our service that we're going to make available to others is going to be iHello service. So it'll be our point where people can connect to us. So we'll then create another project that will test using this service, and we'll try to pull all this together and make sure that we can see that this service is working. Now, we won't put our service on a separate machine, so we won't have some of that realistic capabilities, but it also eliminates a lot of complication for us. So when you're creating your group project, again, you can have things on the same Visual Studio solution, but just separate projects. Now, as we're interfacing and connecting to our service, you're going to see that we're going to be concerned with badges. We saw a badge when we were doing this serializable application. So this is the first time we've run into these kinds of things, and badges are just things that are compiler directives that allow us to identify things as certain capabilities. We're going to have badges that define the different parts of our interface, what is operational, what is data oriented, and then we'll be able to run our test client, our little tester, and hopefully see it communicate with our service and see our results come back so that we can get this kind of feeling that we did this communication. Okay, so let's do it. I've got a lot of stuff here in this thing, but I think we can get past that. Let's close it, or at least minimize, and bring up Visual Studio. Now, I haven't created a project like this on Visual Studio in 2017, so let's see how it goes. We want to create a new project, and we were working with our ASP.NET projects earlier, which of course we might want to use in conjunction with a WCF project. But for this particular application, be a little bit different. Now I'm going to look forward here and see we want to create our service. I think I'll look at this. So we're going to name our application here WCF Test Service. So let's see if we can do that. See what kind of things we have available as templates in Visual Studio 2017. Well, here's WCF. That's just what we want. And we want to create a WCF service application. So perfect. And we're going to name this WCF Test Service. Now, as Visual Studio generates that project for us from the template, we'll see a lot of information that's already available for us. First of all, we are looking at our class, Service 1, and this class, Service 1, inherits from iService1. So we'll take a look at iService1 here in a second. Let's do that now, sorry. I'm just thinking out loud. Okay, so here's iService1. Now, iService1 is an interface, which you read some about in our Advanced Object-Oriented Programming chapter. An interface in this sense just simply specifies methods that must be implemented. So by creating this interface named iService1, we are saying anybody that uses this interface or inherits from it must implement a method called getData. GetData must have a parameter of an integer and it must return a string. So notice this base method definition in our interface. Interface is a really simple piece of code, right? Because it just says you have to do this. Why would we do this interface? Well, we would to enforce standards in our company. So if we have a payroll processing system and we want every programmer to implement a method called log updates, we could create an interface and then require that everybody use that interface so that we can be sure that that log updates method is being implemented in all of the code. Now, looking at our test service here, here are our badges. We are saying that this is a service contract, and in our service contract, we're offering up this operation contract. We're going to call it getData. Now we have another operation contract that's called getData using data contract. So we actually have two methods that have to be implemented if we use this iService1 interface. Now below, we see the implementation for our composite type. Our composite type is basically us saying, I have a Boolean value that I could get or set, or I could have a string value that I could get or set. So really down to the basics. Each of these are data members, so that way I can say that I have these values that are accessible from our class that are called composite types, where we can convert one to the other. So we have these both available in our class. Okay, so that's our service interface definition. Some of it is clear, some of it a little muddy. We'll pull it all together. Let's go back to our service one. Now this service one is a .cs file, but if you notice in between the name and the .cs, it's got this suffix .svc. Well, that indicates to Visual Studio that it's this special kind of CS file as service. And we notice it has its special icon there. Service1.svc has this .cs file as a component of it. And we'll look at the rest of it here in a second. Okay, so in our i-service1 interface, we saw that we had to implement a method called getData. Well, here it is. It expects a parameter value that is an integer, and it returns a string. So just like was required by that iService definition, which we could change however we wanted. And all this getData string does is return this nice output string. You entered this value. Now our composite type getData using data contract method is kind of already pre-coded for us. So it's kind of just an example of what would you do if you needed to return something that was a string or a boolean or whatever you need. So let's fix this up here. First of all, in our example, we wanted to change some of these names. Oh, let's look at this service one before we do that. Now, if you notice when I double click on the .svc, I just see the .cs file. Now, is there anything else in our project that we need to look at? What's this web.config? Now, if you look at the web.config, and we'll be back to it, it shows all of those communication details that we have to establish about how we're going to be communicating with this service. So it's going to be HTTPS. We're going to name it certain things. So that's what our web.config file shows us, and it's in an XML format that might not be completely understandable to us, but it's very readable. We can locate things and find things that we need. Now notice that in this project, Visual Studio did create the app_data folder for you, where your database could reside in this web-based application. Okay, I'm going to close this web.config. Let's start. All right, so in our iService1, let's go to it first. Notice that they have some instructions here. Note, you can use the rename command on the Refactor menu to change the interface name in both code and config file. Ooh, sounds important, huh? So let's do that. We're sitting on iService1. Edit. Where's our little refactor? Well, I know where it is on the right click, huh? We'll just say we want to rename. And I want to rename this. Let's see. What do you think? I'm going to go back and make sure that I... So for our interface, oh, I see. We were going to name it iHello Service. And we normally name interfaces starting with an uppercase I. And I want to rename this everywhere. Oh. It's mad at me for it being so long. Well, let's see if I get any errors. Now, what it did when I ran it, you'll see this too, is it just brought up a file list for my project folder. And that's to be expected. I'll show you how we can keep that from happening. So even though I got the error on the rename, it looks like it did everything properly. Here's our service. Its interface was renamed to iHello Service. If I go to our code, it was renamed to iHello Service. Good. So now, what else do we want to rename? we have our get data method that was already created for us. Let's create a new method called say hello. I'm going to close and reopen Visual Studio because it's not letting me make any changes. Maybe my rename crashed Visual Studio. So I want to reopen this project that I was just working on. Make sure everything looks okay, and it does. So now it's letting me type, that's good. So I'm in my iHelloService.cs interface file, and I want to add a new method that my users can call, and this is going to be an operational contract. They can run it, it'll operate, right? And so in this operation contract, I'm going to say that I want to create a new method, and it's going to return a string, and it's going to be called say hello, and it's going to expect a string as a parameter. Now that's all I need to specify in my interface. I'm saying whoever uses me must implement this method, say hello. Now if we go to our service1.service, we can add that in. Now we're getting an error, and it says service1 does not implement interface member iHelloService.say hello. Well, that's true because we haven't added that method to our code yet. So notice that that's the cause for our error. Now, would you like to rename our test service? Nah, we're fine. Let's leave it named service1. I just want them to be named something different enough that they make a little bit of sense. So in our class called service1, we need to add a new method to satisfy the requirements of our contract, and it has to be named say hello, and it has to return a string and accept a parameter of a string. Alright, so let's return from this a formatted string. It says something like hello. Parameter. And for our parameter, we'll use the name. So it looks a lot like that get data method, doesn't it? But now we have this new method called say hello. Great. So we've created our little service here, but as I showed you, if I just run this application, instead of getting anything that tells me anything about my service, I just get a list of the files in the project. So we have to run this a little bit differently. We have to be on our class, service1, and then we should be able to right click on it or do we just run? Let's see what we got here. I think it's weird. We just run from this. Let me try it. Yeah, there we go. So notice how I didn't do anything differently in running my project. It's just which CS file is current in my window. So if I'm looking at my service1, my service that I'm implementing, I'm going to get this WCF test client. If I'm looking at some other .cs file in my project, I'm just going to get a list of files and folders in my project folder. So be careful with that. Okay, so let's see here. It looks like our service is named service1.svc, and internally it has an interface, iHelloService, that uses basic HTTP binding, which we could update, and it has a method called getData. So I'm going to click on that. There it goes. I double click, sorry. And in my getData, I have to have a value. So let's put in a value. Oh, here it is. I can type it. So if I type this value and I invoke my service, I should get a return. You entered 32. Perfect. So it tested my little getData method. Now let's test our sayHello method. Double click on it. Now sayHello wants a name, and then it will issue a response. So let me put a name in and invoke that method. I don't need to see this warning anymore. And now I get a response back, hello, comma, Renee. So I've just tested both of my methods in my service by using this WCF test client. It has some capabilities, but not a lot. I mean, this is what it's for, is to test your basic service. Great, so we created a service. Now, we would actually set this up on a web server somewhere to run and to be accessible. So a lot more work on that end, you know, getting a domain name and setting it up and have everything configured correctly to point to your service from the network point of view. It might require a network administrator's assistance. It's not something that you should be able to do. So that's why all these facilities are available in Visual Studio to help you with that. Okay, cool. So I'm going to close that. And now in Visual Studio, looking at my solution, I'm going to roll up this project and close out these tabs to get it kind of out of my way, because now I want to create our tester project. And so let's do that. I want to add a new project, and we could make this any kind of project that we like. Let's make ours a forms-based. So I'm going to do a Windows Forms app, and I'm going to call it WCF Tester. Set it up all nice for us, and let's put in a label. And I just want my label to say, what is your name? In the text box. And we'll name this TXT, BX name. And then beside that, I'll put another text box. And I'll name it TXT, BX name response. And then we'll have another label. And for this label, we'll say, what's your favorite number? And this will be TXTBX number. And then one more text box. And we'll call this one TXTBX number response. Now I'm going to put a button on my form to kick everything off. BTN, okay. And I'll put its text as test service. Now I'm going to select everything on my form and change my font to be a little bit bigger because I didn't do that by default. And we see that it can be a little bit harder to see when you're watching the video if I leave it that default. Okay. So not too fancy. Let's put in our code. Now this program is going to need to, this project is going to need to communicate with our other project. So we have to have some things, you know, in cahoots a little bit with each other. We want to make sure they can communicate properly. So let's add some code. We want to create an instance of our Service 1 project. So first of all, let me check and see how things are set up. Let's see what happens if we just type in its name. It's like, no, I don't know what that is. It's giving us a problem. So what could we do? Could we add a reference to it? It's just mad at us, isn't it? It says the type or namespace service 1 does not exist. Oh, it doesn't, does it? Because this needs to be WCF test service. And what have we got in there? Nothing. So let's put in a reference. Add a service reference. Look at that. That's new. And that's what we want to do. Now, we don't have any addresses here to connect to. So there's a few things that we have to do. Let me cancel. I just wanted to show you that all of these normal things that we try might leave you feeling a little inept. And that's okay. We're used to that. Now, what I need to do is run my service. So I'm going to go back to that service1.svc file, remember my code, and I'm going to run. Now my service is running. It is running on my local machine under this address, right? So I'm going to copy that address. Now I can leave this running or minimize it, but yes, I do have to have it running. Now I'm going to switch back to my other program. And try this again. Now what we need to do is add that service reference. So in our tester project, our new project, instead of just adding a reference, we're going to say that we want to add a service reference. Just not letting me do it at all, is it? Well. I'm going to just delete this whole project, which, well, let's create a new one in Visual Studio. Now this new project is going to be a Forms app. It's going to be WCF Tester. Just not liking it being in the same solution, is it? Now my WCF tester. Be fine. I'm going to go back to my previous project and select all on my form, Control A, then I'm going to Control C, go back to my new project and Control V. Now I've got all those form fields because I didn't want to have to create them again. And I'm going to go back to my previous project. Stop running. Hang on for me. And I'm going to delete this tester. Okay, so now our WCF test service project only has our service in it. If you notice, our server needs to be running in order to connect to it, but we can't have it running and be working on our other project. So we're kind of stuck between a rock and a hard place. So instead, we'll create two. Now I'm going to start my service again. This address should be the same. And now I can minimize this project. Now my tester project, I'm going to add my code. No, thank you. Sorry, everything's so obnoxious. Now, we want to add that service reference. So I have that address copied. I should just be able to paste it. Of course not. Let's go back to it. Copy address. And try and paste again. Now, is that going to work? Let's try it. Good. Oh, it found it. It says, sure enough, I see this service, and it's running on your local host. And here's what that service has. It has an interface named iHello service. And in that interface, it makes available these three methods, these three endpoints. Get data using data contract, and say hello. Awesome. So it made that connection. So I'm going to click OK. And now in our references, we have our service reference set up. And it's right up here. It kind of shows it a little differently. Connected services, service reference 1. Awesome. So now I can refer to that in my code. Service reference 1 be our server. I'm going to add in a using just to see if that helps us. That's our code. Lots of different ways we can do this. Let's try one here. Let's see, what if we do I'm going to set up a string to be a reply, and I'll set it equal to our service reference 1 dot I hello service. Oh, I see what I need. Sorry about that. There are so many different objects. Sometimes it's just confusing. So we want our hello service run 1, right? So sorry, I got quiet on you there. Okay, so when I'm looking at creating an instance of a connection to that service, it's going to be a client. So when we generated our service, it created this hello service client for us. So that's why it was something that is buried in there. So it's part of our service reference. So we could add that using clause back. Let's try it. Just a little different, huh? Well, we'll just put the long name. So we're going to create an instance of our client, our hello service client, and this instance is going to be named client. Now, I can set my text box name response dot text equal to using our client running our say hello method. And what do we want our client to say hello about? Well, whatever their name was that they typed in that text box. Okay, so we're saying I want to create a text value that is equal to the response I receive from the say hello method when my client runs that method. Now I want to set my number response equal to my client running. For that one, what did we have? It was called something else. Was it get data? And it wants an integer. So our integer that we're going to pass is going to be from that text box, number.text field. Can't just cast it as an integer, huh? So we'll say convert.to int 32, that text box value. Not an unsigned integer, an integer. All right, so pretty easy code once we got our connections made to our service. And again, notice our service has to be running. And this is not normally an issue because if this service were previously developed, it would already be running on some web server. And that address that you would enter in to create that service reference would be that web server's address. And so you'd be able to make that connection. Let's run our program. Okay, so my response from the web server is hello Ray, and you entered 45. So our service is working, everything's awesome. If I were creating this service to return a price, you know, I might access a database back in that method that I created in that service. So think about all these pieces. I know there's a lot of these pieces that are going to have to fit together, but each piece is very simple and not really that complicated. It's just the connections that are a problem. Now, what if I moved my service to some other server? I could double click on this service reference 1 information, and I would be able to find the properties about this. Maybe right click, let's try that. There it is, right click and choose properties. No, no good. Come on, where are you? Wow, it would make it difficult, wouldn't it? Should be able to, but I'm not finding it in this new version of Visual Studio. So we might have to do add service reference again and just create that same piece of information, or delete this one and add it again. So be aware that, you know, these kinds of updates, that's why people don't like to change the name of their web server. Remember that network changes like that can have a huge impact on our applications when we're running these kinds of things that are dependent upon those interfaces and names. So in our application, we used whatever protocol we specified in our service. So remember, in our service project, we had that config file that allowed us to enter that information. As a programmer, again, in general, that'll be information that you don't have to worry about creating. It'll usually be given to you. Okay, so we created our service. It really is not that complicated. Walk through it, take a look at the textbook, kind of get a feel for all of the different pieces. And as long as you're having an understanding of the fact that this is possible, that's a good step in the right direction. Thank you.